have three equations again. None of them appear to be parallel or the same line, so let's continue on doing what we did just a moment ago. Let's write this as an augmented matrix. First row, 1, 3, 9, 12. Second row, 2, 7, 22, 26. Third row, negative 5, negative 17, negative 53, negative 64. So no problems yet. Now I want to get zeros in that first column beneath the 1, and to do that I need some opposites. To cancel out the 2 I need a negative 2. So negative 2 row 1 plus row 2 will give me the new row 2. And to cancel out the negative 5 I need a positive 5. So 5 row 1s plus row 3 gives us the new row 3. Here we go. Row 1 is going to stay as is, so let me rewrite it. 1, 3, 9, 12. We're going to have zeros in that first column by design. Now let's figure out the rest of it. Here we go. Let's work on equation 2. Negative 2 row 1. So negative 2 times 3 is negative 6, plus that 7 makes 1. Negative 2 times that 9, that's negative 18, plus 22 makes 4. Negative 2 times 12 is negative 24, plus 26 makes 2. So that's coming out nice and clean so far. Let's work on this bottom one. 5 row 1s plus row 3. 5 times that 3 is 15, minus the 17 makes negative 2. 5 times the 9 is 45, minus the 53 makes negative 8. 5 times this 12 is 60, minus 64 makes negative 4. So far so good. We have the 1 already where we want it, so I now need zeros above and below it. To cancel out this 3 I will need a negative 3, so negative 3 row 2 plus row 1 will become the new row 1, and to cancel out the negative 2 I need a positive 2. So 2 row 2s plus row 3 will give us the new row 3. Okay, we know what the first two columns will look like. It will be 1, 0, 0, 0, 1, 0. We know the middle row is going to stay the 0, 1, 4, 2. So now we just need to finish off row 1 and row 3. Here we go. Negative 3 row 2s plus row 1. So negative 3 times this 4 is negative 12, plus the 9 above it makes negative 3. Negative 3 times this 2 is negative 6, plus the 12 above it gives us a 6. Now we're going to go 2 row 2s plus row 3, so 2 times 4 is 8, minus that 8 makes 0. 2 times 2 is 4, minus 4 is 0, and we got another oops, but this time I don't have a 0 equals negative 5, I've just got a whole row that means nothing. So basically my equations my system turns into this. I've got x minus 3z is equal to 6, and I've got y minus 4z is equal to 2. Now, this is not a no solution problem. There is going to be a solution, but we need to figure out how to represent it. Basically, what we have here is two planes, and two planes, if they're not parallel, will always intersect to form a line. So I want to note something here. Note that x and y are each in terms of z. In other words, I can rewrite x as 3z plus 6 and y as 4z plus 2. Okay, that allows me to write my solution set in a special form. I can say my solution set is the set of all points x, y, z such that x is equal to 3z plus 6 and y is equal to 4z plus 2, comma, where z is a real number. Well, usually we take this one step further and we write it in yet another form. We write this in what's called a parameterization, and we say this is going to be something of the form x, y, z, where my x is 3z plus 6, my y is 4z plus 2, and z represents itself, where we say z is the parameter. Sometimes instead of using the letter z itself, sometimes we see this written as 3p plus 6, 4p plus 2, comma p, and I guess the letter p here is chosen because it's the parameter, but your choice on which format you're wanting to use. This is a set of points which is really a line. We're used to lines being y equals mx plus b, but this is an xyz type of line. And if you wanted to generate points that are on the line, you choose different values for p. For example, if p were 0, we'd have 3 times 0 plus 6. We'd have 6, comma, 2, comma, 0. That will be 1 point on the line. Then you could say, let's let p be 1. I'd have 3 plus 6 making 9. 4 times 1, 4 plus 2 making 6, and that will be another point that's on this line. And you could generate points on that line one by one by one by substituting in different values of p. So we will probably be going with this first representation with the z in it because it's the most compact, easy way to write our solution set.